Here we go. All right, so from here on, good morning, everybody. This Zoom software is opened up to accept more than 40 minutes, but I had to apply for it. And it said it could take more than 24 hours. So if for any chance the video does stop, which is probably likely at the 40-minute mark, it could happen. I had this on for a while, so it could stop in the next 5 minutes. Whenever that happens, go right back onto Schoology. I will start a new one and I'll post the new information. I know it's not optimal, but for today, that's what's going to happen until that kicks in. And then hopefully tomorrow, it just gives me unlimited time. So that shouldn't be a problem. So again, if this video stops, we're going to go right into Schoology again. And I just wait for me to go ahead and start a new one and invite everybody. Okay? Going forward, I want you guys to start working on this. So you're going to draw a plane intersecting a cube to get the cross section indicated. So I'll do an example of the first one. Scalene triangles. You're going to imagine a plane. You can use your hand. It's going to be funny because I'm going to call this cheese a block of cheese, and we're going to cut the cheese. So, Maybe some of you don't even know what that means.
It's hilarious.
I know. So here, you're going to imagine you have a knife, and you're going to cut through this block of cheese. When you cut through the block of cheese, you're going to take that.
It's a caution moment.
Okay, you're going to have to mute yourself. You have a question. Okay, you're going to take that block that you cut from the cut. You're going to look at it. When you look at it, what is the shape? It's going to be a cross section. These are what you want to see. So I'll do the first one. When I cut through, I'm going to do this with points. I'm going to put my knife through that point right there. And I'm going to cut down at an angle into the cheese so that, let's see, I want it to come out here and maybe over there, like that.
Turn your video on.
Okay.
David, your video's on.
David, turn your video. I'll just stop your video. There you go. Okay, so you can see right there, that would give you a scalene triangle if this right here is a different distance away from the corner here than this one. Okay, and then as I cut down, I have this little triangle that you can show, you know, when you pull it off. Okay, so that's what you're trying to do. See if you can come up with an isosceles triangle. Now, if you have one on your paper and you want to show one of them, pick one that you might want to show. And then you can put your video on and hold it up in front of the screen if you'd like, so that we can see what students are getting. Let's see, I'll read while you guys are working on this. In a little bit, I'll do the next one and then the next one. I think you should mute everybody. Every time they speak, they interfere. Not really. We'll see. If it becomes a problem, I will. Oh, you want everybody to turn off their audio. It's harder to hear. I'm not hearing anybody. Yeah, if you guys want to keep it on mute until you have a question, that probably would work fine. So just everybody put your audio on mute, and then if you have a question, then unmute it and ask your question. And that way I don't have to read the comments too much. You could just unmute and ask the question and then remute. Okay, I'm going to start setting up the next one. These are kind of fun and they can get difficult. I don't know if you guys are having difficulty with any of them. Okay, for an isosceles triangle, I'm going to come in the same point I did before, but I'm going to make sure that this distance from here and here matches from here, there, and there. Okay, so that this distance as I come across, as I cut through, is the same, and I get an isosceles triangle. Pretty cool. Okay, so that little block's going to come out. And if you have questions, unmute and ask. I shouldn't be hearing you guys breathing into the mic, so go ahead and mute yourself unless you have a question. Next one you're working on, well, equilateral, we can just do that right away. These might be the same, but they're not the same as the bottom one necessarily. So then if I just do the same thing but come out to the corners instead. Then the bottom is the diagonal of one of the square faces. this side, left side of the black triangle that I'm making is a diagonal of one of the squares. And so is this one. So they're all going to be the same length. So then that gets you your equilateral triangle. Keep going. So I would say that if you try to make a trapezoid, you're probably going to make an isosceles trapezoid. I wonder, can you make a non-isosceles trapezoid? That's a little harder. I'm going to get rid of this one while you're working on that. Okay, let me fill this in here. Anybody have one? Like just a regular trapezoid? They want to hold
What?
it? Anybody make one?
Okay.
If you have one that you made on your paper and you want to show it, put it on the video. Yes, I'm cutting through the plane. Oh, okay. So Joseph's saying, I think you should just mute everybody. Every time they speak, they interfere. The screen replaces my screen. Okay.
You
Joseph,
could
if
pin
you go
his
to his
screen.
video and you go into the drop-down menu, you can pin him and it won't replace your screen.
Oh, did you hear that, guys? If you right-click my video and you can pin it, and then it won't replace the screen. So that's
Okay.
a good way to stop that from happening.
But it does kind of get annoying. Okay, but thanks, Nigel. Okay.
That's fine. Just go ahead and mute unless you have a question, and that'll work nicely. Right, and whoever's breathing, exactly. Noah's right. If you're breathing into it, you need to mute yourself. We can hear you breathing.
I found out that Joseph was the one breathing.
Yes.
Yeah,
My mic was right in front of my nose, and I didn't realize that I was detecting audio until Ben called me and said,
all right. Let's get back to the video. Okay. All right. So let's go on. So nobody put a picture up, right? Nobody put a picture up. Now, if somebody but you know, if everybody pins mine and they put a picture up, they probably won't be able to see it anyway. So let's just go to here. All right. So trapezoid. Let's see. How will I make it? So if I do maybe something here, and I go to here, and then I put this one back here, and it needs to be the same. It needs to be at the same slope as this one. So if this one's like this, then this one has to be also the same. So wider. Maybe something like that. But I mean, would that looks like it's twisted though. I don't think that would work.
That's just
me
the
just make-
way you're looking at it.
Yeah, so let me do this. There are the corners right there. And then what I could do is I can come to these corners out here. That. Okay, so I can cut through the block and then angle it and come out the corners. Okay, and get a trapezoid. All right. Now, if these are the same distance from this corner, then you're going to get your trapezoid. All right. So, and then that one will be isosceles. All right. Parallelogram. Go to the parallelogram. Fix this. I can hear you. You got to mute yourself. Moto Z plus, whoever that is. Okay, so parallelogram, you can just make it a rectangle. You can go, let's say, we can go from here and here and then just come down here. Do the same thing. And it just comes through there like that. Okay, that's easy to do. Okay, you guys, you want to undo your video if you can. I'll stop your video for you. Okay, there you go. All right, rhombus. Do the same thing you did there, but you want to go through maybe, so it wouldn't be a rhombus if you went through the corners, right? Because if you went across, that would be the diagonal of a square and the bottom would be, but then you would come down straight and that would not be the diagonal of a square. So how would you make sure you got a rhombus? Maybe cut through this direction.
You have to cut through the bottom corners and in the middle of like the side kind of, at the top.
Well, if this is a cube, then the distance across the cube perpendicular to it, and that distance, and then across that way, and that like that. Okay? So instead of angling towards the corner like the green one, make it parallel to one of the faces. So just a true, you know, straight up cross section. So Ava, we want to undo your video. Can you hear me? Ava? Okay, thanks. All right. So there you have your, that's going to be a rhombus. It's going to be a square, basically, which is a rhombus. How would you do the Pentagon? Anybody do that one? That one, the Pentagon's cool. To me, the Pentagon and the hexagon are easier than the other ones. The trick to the Pentagon is to think, well, how many points of contact need to be made? 5, right? You're going to need to make 5 points of contact. So you might want to scout out where are those points going to be to make 5 points of contact. So let's see what you got. I got this. 1. That's going to be the top. As I slice through, think about the knife is going to be cutting along, right? As you're cutting the knife, you're going to see it going through the cheese until it disappears behind it. That's a point of contact. But if the knife is really long and you're cutting through the whole thing downward, it's also going to come through that way as you're angling it down. So you're basically cutting down diagonally away. It's hard to see, I know. And you don't want to come out the bottom. You want to come out there and there. There you go. That's going to make a pentagon with the block of cheese. Hopefully everybody can see that. Yep, you can see it. And then once you do that, it's kind of, I mean, it might be more intuitive of how you would make that a hexagon. Where are you going to pick up your 6th point? I wonder where you think your 6th point would be. So anybody, I'm not getting any questions, so I gather that somebody is showing me some other screen. I don't know how that happened.
Yeah, it's like it's Jillian.
It's Jillian.
Oh, well, that's interesting. Okay, there we go.
How'd you do that?
Yeah, that was weird. All right, so we're all getting used to it. So here we go. How am I going to make this a hexagon? Did somebody already do it? We need 6 points of contact now. You can still come in. Oh, wait, no, you don't. What you do is you don't come in from the corner. That corner, you can split it if you
come in from the top.
Yeah, you come in from the top. You take this point and you split that into 2 points of contact across the top, and you avoid the corner. You come in from the top face, exactly. And then you do the same thing. You come through here, come through there, and then you come out the bottom there. There you go. There you got your hexagon. All right.
I seem to remember reading that it cuts halfway through the cube exactly.
When you do a hexagon?
Can you hear me?
Yes.
I can hear you, yes.
Okay. I think my microphone was messed up earlier.
You're good now?
Yeah. I have a question though.
Okay, go ahead.
You said if you want to turn on your video to show the answer, you can do that, but I can't turn on my video because you stopped it and it won't let me turn it on.
Oh, okay. Well, I don't know how to turn yours back on. Maybe if I went to participants, I could do that.
Okay.
Yeah, I think I can.
Accident. It's just an accident.
There you go, David.
Okay.
Okay, so you wanted to show? Okay, do that again.
I had something to show, but it was not on a different thing. But for the rhombus, you can just cut the cube in half. You'll get a rhombus.
That's what the other one that I showed
The
was.
square is a rhombus.
Yeah, that's what I had showed. Okay, good.
All right.
Everybody, are you warmed up? Let's move on. Remember, if the video, for anybody just joining, if the video cuts off, what I'm gonna do, since I wanna go to 9:30 about, if we cut off early because we've reached some mark for doing this, then automatically go on Schoology and wait for me to give you an invite again. I will just invite and start a new one. Okay, and then hopefully tomorrow we don't have to do that. Maybe we don't have to do it today. I think I've had this one on for more than 40 minutes. So maybe we're good. People thought that this was gonna crash. Okay, here we go. These are nets. Let's make sure this is the next one. Yep. So these are nets. Can you tell what they're nets of? This one up here. What is that a net of?
Cube.
Yeah, cube, exactly. It's a rectangular prism, but all the sides are the same. What about this one? What was this?
Cylinder.
Yeah, cylinder. Okay, so the way that geometry tends to teach this stuff is by making a net, so you understand that when you're doing surface area, all you're doing is finding the area of each piece, and then you're just adding them all up. So go ahead, I'm gonna time you. Take about maybe a minute to a minute and a half to get the areas of these two. And that would be the surface area. Go ahead. So you have to remember, not really chapter 10, just basic, area of a square, area of a rectangle, area. You're gonna need to know something about that. I don't wanna give that away, of the cylinder. You might be thinking, how do I get this length here? But you can figure that out. Don't say it out loud. While you're doing that, I'm gonna get this one ready. "35 seconds.
Got it.
All right. Mute yourself unless you have a question, please.
Same.
Yeah. So when you say got it, I'm guessing you have both.
Yeah.
Yeah.
Yep.
Okay.
Mm.
Okay, you guys, don't ask me if you can use the restroom. I'm not your guardian at this time. When you're in school, I am, but right now, you don't ask permission. I think you're just being funny.
Guys, he's
And you
wearing a
gotta
Ghostbusters
smile at
shirt.
him. The what?
He's wearing a Ghostbusters shirt. Do you really think he's gonna stop you from going to the bathroom?
I really don't have that much power to be able to stop you from using this. Okay, let's go over the problem. We're a minute and a half in. Everybody stop what you're doing and take a look up here. Okay, so for this, you're basically finding the area of each one of these. So it's 4 by 4. So it's 16, and then there are 6 of those faces. So it's basically 16 times 6.
So you get 96.
Yeah, you get 96, and don't forget your units. We're measuring area.
Centimeters.
Centimeters squared.
All right. Now, this one's a little bit more hidden, but if you were to take a cylinder, you could actually do this with a piece of paper and ravel your paper into a cylinder. And then you can see when you make your paper into a cylinder, there's a slit down. You didn't slit it, you just folded your paper. If you were to unravel it, you can see that it forms this rectangle. But the height of the cylinder is right here, but the length is not given.
It's the circumference of the circle.
That's correct. So this is going to, if you look at it, will wrap exactly around the circle. Okay, so the circumference, we said, is the diameter times pi. Okay, so since the circumference is the diameter times pi, and they give you the diameter of the base, it's just going to be 4 pi. So this rectangular piece is 4 pi by 8. So we can come over here, we can get the area of this piece here.
32 pi.
Yeah, it's 32 pi, and that's square units. Okay, And then don't forget, you have 2 circles. Okay, so if you have 2 circles, go ahead and find the area of each one. The area of the circle, we remember, is pi r squared. Okay, the radius is not 4, it's 2. So you need 2 squared times pi. So it's 4 pi for each circle, and you have the one on the top and the one on the bottom. So you have 2 of these. So you have 8 pi.
8 pi plus 32 pi equals 40 pi.
And look, notice we're keeping it in terms of pi the whole time. Don't multiply here and then round, multiply here and round, then add them to, no. Keep everything in terms of pi now. Add them together to get 40 pi. Okay. We don't need this anymore.
It's nice and neat, 40 pi.
Yeah, and you know what? For right now, just leave it. We don't need to do anything else with that. So I would write my answer 40 pi, and we're in centimeters. So square centimeters is the total surface area of the cylinder. So that is the traditional way. You know, for 6th graders, when I'm doing geometry with them, I'm going to teach them this as well, same thing. Okay, but you guys are going to get maybe some more advanced connections to the geometry than they're going to get. Okay, any questions?
Yes.
Okay, go ahead.
Look, I don't really know what I did wrong, but I ended up getting 2 open parentheses, pi 32, close parentheses, plus open parentheses, 8 times 4 pi.
Like
This
that?
gives a very, very weird answer. Yeah,
Okay,
that's what I got.
I can explain this. This is explained with this. But I cannot explain this.
Excuse me, Mr. Rosenthal.
Yeah,
We can't see the bottom of your board.
it's in my video.
Yes, we can.
Change your plan.
We
I know-
can see the bottom of
Yes,
his
we
board.
can.
Okay, well, don't yell. He obviously cannot, so that's a good way to communicate.
It's probably because you're on an iPhone.
Maybe, I don't know.
Oh, roasted.
Never mind, actually.
No, you guys, that's not what this is for. So you mute yourselves unless you have a question. Or if you
I know
want-
exactly what I did wrong, actually. It's fine.
Maybe you
this
should go on landscape.
I can't explain this here. So Daniel, can you tell me what you did? What's the 2 pi? Here, I'll put it up.
Mr. Rosenthal,
Yeah.
I actually know exactly what I did wrong. I just figured it out. Now I got the normal answer, so I'm fine.
You got it?
Sorry to... Yeah, I got it.
Yeah.
Just
Okay.
a careless error. Very, very careless error.
Don't worry about it. Okay. Anybody else? No? Okay, we're going to move on to the next slide. Here we go. See what we got. Okay, so I mentioned this in the last lesson, what a prism is versus a pyramid. This doesn't mention a pyramid, but I just want to review that again with you. The 2 types of objects that we're going to be talking about this chapter are prisms and pyramids. And one of the biggest differences between them is the number of bases. Okay, so a prism whatever the base is being stretched to a new dimension. So the 2 dimensions becomes 3 dimensions. Okay, and we call it this one was a triangular prism because we started with a triangular base. Okay, if the base was a hexagon and I stretch it up, I gotta make another hexagon. That's not so much fun. Okay, along these lines, vector paths. Okay, then that's called a hexagonal prism. So you got to pay attention to the 2 things. There's name of the base is just the name of whatever the base is. Hexagonal, triangular, rectangular, circular. Let you think about that one.
That's a cylinder.
Yeah, exactly. So a cylinder it would be like a circular prism, right? If you wanted to think of it that way.
Yes, except a prism is a shape bounded by polygons, and a circle is not a polygon.
Well, you could think of the circle as a regular polygon of infinite sides, right? Okay, so but this is a prism. Later on, what happens if I have that same triangle, and as I'm stretching it at the same time, these 3 points are actually not going straight up, perpendicular there. they're all converging on a point. And the point, by the way, doesn't have to be right above. It could be over to the side. That's going to create an oblique pyramid. And then you get this.
It's a pyramid.
Yeah. So what's the difference between these two? Well, their nets are going to look different. The faces that go around the bases are the lateral faces, are rectangles here. Here they're triangles. Okay, so let me make that dotted. Okay. All right, so those will be triangles. So you can go ahead and look and see, I mean, how are those going to be different? So this would be, you still name it by its base. It's still triangular, but you don't call it a prism anymore. You call it a pyramid. So those are, always break these polyhedrons into those two components. Find out what is the base, how many of them are there. If there are two identical bases, well, you have a prism. Okay, if there's only one base and the other side it's not there, it comes to a point, it's a pyramid. And you know, students get these two things mixed up, so you have to be careful.
Triangular pyramid made out of equilateral triangles is a tetrahedron.
There you go, tetrahedron. Thank you for that. Okay, the altitude. Let's talk about that. If you have the two bases, and let's get back to prisms. We'll get to pyramids later. But with the prism, think about the connectors. What are the connector segments? And what am I talking about when I say that? It's these segments that are all connecting the two bases together.
Altitudes.
Yeah, and what's true about all three of them? Or all six of them? Or all eight of them? They're all congruent.
And they're all altitudes.
Yeah, and they're all the height. So if you want to know what is the height, sometimes these things are going to be turned on their side or rotated funny. Sometimes students, when it's laid on its side, check this one out. Oh, wait, I want to make sure it's up high enough. So I'll do it over on this one. So here's one where students think the height is not what the height actually is. Think of a tent. What does the tent one look like?
It's basically like two scalene triangles.
Yeah, and so what I'll do is I'll say, well, the height of this triangle, right, that has a height, but that's not the height of the prism. So you're going to see me do to differentiate is I'm going to call the height of a polygon little h, and I'll call the height of the whole prism has to be the segments that connect the bases. So I'm going to call that capital H. Little b, right? I'm going to use for the base of one of the polygons or the bases, okay? I'm going to use big B later to represent area of the base. I'm going to use capital B. All right, so as we go three-dimensional, that's just my way of helping you guys to know what I'm talking about. That is not the height of the prism. But students think, well, base means the ground, and I'm going to come up off the ground, and that makes total sense. It's a rational thought that would be the height of the prism. It's not. The height of the prism must be the connector between the bases.
Little b represents what again?
The base of just this triangle.
Okay, thank you.
Big B later on will be the area of the base. Okay?
And then big B, big H is the volume.
You're right. You're ahead. Yes, exactly. Okay. Now, I could take this top base here and slide it over and leave the bottom base alone, and it will tilt. Okay? So that's okay too. That's called an oblique prism versus a right prism. Almost everything we're going to deal with is going to be a right prism. Okay? We're not going to be dealing with a lot of oblique figures. Okay? And it will be a right prism unless we say otherwise. Okay? Moving along. Okay, there's some pictures. Take a look at this. Now, the cool thing about a rectangular prism is the bases are optional. Okay, I can have the front be a base. Then where's the second base? The back, right? They're opposite each other. I could say the top is a base, and then what would be the other base? The bottom.
It would be the bottom.
Yeah, and then the right could be a base. And then the left would be, only with this one can you do that. Only with the rectangular prism. Okay, remember with a prism, All the other faces are rectangles. The lateral faces are rectangles. Okay? Look at this one. What type of prism is that?
That is a trapezoid prism? I don't know how to put
Yeah, trapezoidal. Trapezoidal prism. So what a student would get wrong here is they would think, oh, that rectangle down there must be the base because it's on the bottom. That's the big misconception. No, the base is, you're looking for the two identical congruent, you know, bases where you pulled one and stretched it out. Okay, you did not stretch that rectangle into the little rectangle at the top. You took this trapezoid in the front and stretched it back, or you took the one in the back and stretched it towards you. Okay, so those are the two bases. So the height, of course, is this red piece that connects those two bases. Okay, the height is the length of the altitude. And then there's an oblique. So this is not going up at a right angle, it's tilted. What that's going to do is it's going to change the surface area. But guess what? It's not going to change the volume. That's pretty weird. It does not seem intuitive. But we can talk about that.
Well, the formula for the area of a parallelogram and the formula for the area of a rectangle is the same.
That's true, but the area is not going to be the same. This area.
I know, but the base.
Look at this right side. This right side is not going to have the same area once you tilt it. Now, the best way that you could think about
the base.
Hold on. The best way you could think about that is that you can think of this as a stack of Post-it notes. A big. I don't know
The pink parallelogram is going to have the same area.
Okay, hold on. So you're going to have a stack of the Post-it notes, and you start to lean on it. And what happens is the Post-it notes start to come diagonally like that, and it looks like that. And what you would notice if you looked at it is some of the Post-it notes you can now see are exposed where they weren't before, which means it's opening up more surface area. So the surface area is going to expand. But with the volume, it's the same amount of Post-it notes that you started with. Just because you push it over, you don't gain or lose any Post-it notes. So the volume stays the same.
Yeah.
That's a pretty good way to think about it. Okay.
For the trapezoidal prism, would you find big H by averaging both H's? By both little.
Wait. That is big H. I call it that, but this is from the textbook. They don't do that. I do that. So I don't want to mix you up there. That should be big H. It connects the two bases at a right angle. It is perpendicular to the bases, right? Or the planes that contain the bases.
Yeah, I mean, plus the bases are parallel, so both H's are going to be identical.
So little
yeah.
a.
Now this one, all of these should be big H. That should be big H also.
So the little h for the trapezoidal prism is the height of the trapezoid?
Yep. No. It's the height of the prism.
So the little h is going to be like the height of an altitude, and then the large h.
So let me say it again. Don't get confused. This was from the textbook. They don't do little h, big H like I do.
Okay.
So
They
this
do H1, H2 maybe.
So this, if I were drawing this, I would call this big H. And I might make an error. I might accidentally call it little h, but don't get hung up on that. All you have to know is whether I call it little h or big H, you should know the height of the prism is different than just the height of the trapezoid here. The height of the prism has to be the connector piece that connects the two bases.
Will you accept H1 and H2?
Yeah,
Okay.
that's fine, as long as you know which one is which.
Yeah.
This is how I do it. When I do it, this is how it helps me to differentiate. Okay. Why do I use capital? Because it's another dimension up from the other one.
Okay.
Okay.
So if you went another dimension up, what would you use?
I don't know. I don't have to do that, luckily. Okay. So this says what we already talked about. In a right prism, the lateral faces are rectangles, and a lateral edge is an altitude. Okay. So in this book, you may assume that a prism is a right prism unless stated or pictured otherwise. Okay. So the lateral area of a prism is the sum of the areas of just the lateral faces alone. So this is how we're going to make a master formula out of this. We're going to separate the area of the bases from the other area. Everything else is going to be lateral area. And it's just all made of rectangles. Okay? And so the surface area will be, when you add those all up, you'll have two bases plus all of the lateral faces. Now it can be, the base could be an n-sided polygon. You could have a lot of sides to your base. For every side of your base, that's another vertical face that comes up to meet the other base. So you'll have a lot of lateral faces. If you have, I'll say it this way. If your polygon that makes up the base has n sides, then you're going to have n lateral faces that go around. So for instance, here you have a hexagonal base. You're going to have, which is 6 sides. So you're going to have 6 lateral faces that go around. If you just look at one of them, you'll see, like in the back there, that side makes up a rectangle. Okay? When you have a pyramid, these two come together into a point, but on the bottom it doesn't. So these two come to one point, so all of the lateral faces will be triangles when we get to pyramids. Good. I think you guys can do an area problem now. Okay, here's another visual. So here you have pentagonal prism and a triangular prism. This is like on its side, so the bases are here. Notice in this one, what are the other faces that are not blue and green? What shape?
Rectangles.
Yeah, they're all rectangles. Doesn't matter if it's pentagons. Look at this right here. I'm tracing with my finger. Rectangles, right? So the lateral area are all the rectangles that go around, and then you have the two bases. To find the total surface area, you need to add them all up. So go ahead and find the surface area of that. 30 seconds. This is one of the easiest ones that we can get. While you're doing that, I'm going to erase the board.
So, Mr. Rosenthal, the lateral area is the area of all the rectangles attached to the base in a prism, right?
Yeah, it's all the non-base faces. All the faces added up that are not the bases, excluding the bases.
And are we finding lateral area or
Thank you.
surface?
It says surface.
Okay.
94.
Well, we don't want to.
Really easy.
We don't need to shout out the answers. Okay, so let's see. You could make this a net if you wanted to. But watch this. If you have you can make the front and back are the same. So the front is 4 by.
Marco's not so good.
Okay, there's the front and the back are both 20 each. And then you can do top and bottom.
Better.
This is just one of many ways to organize it. What are the dimensions of the bottom? 4 by 3. So this area is 12, and there's 2 of them. And then you can do the area of the, what did I miss? Right and left. Right, right, and left. So the right side would be 3. Now look, the height of it's all 5, right? They're all the same. So this one's 3 by 5, 15. So it's basically all the combinations you can make. You put 3 with 4, 3 with 5, 4 with 5, right? And you get these areas. But there's 2 of each. So you need to double all these. So there's 2 of those. There's 2 of those.
30, 24, 40, 94.
Yeah, and then there's 2 of those. So this is a very organized way of doing it. You don't have to do that, but you know, if you have time on a test, I would take your time and get it right. So then you add them all up. You get 70 and 94. Okay? So your final surface area is 94 square centimeters. Okay, any questions about that?
No, it's pretty self-explanatory.
Wow, 60 minutes is so short. It looks like we're not getting cut off, so that's good. Hopefully it's still recording. Yeah, it still looks like it's recording, so we're good. And I'm going to post this on YouTube afterwards.
Oh, okay, so we can look back at this?
Absolutely.
All right, thank you.
Yeah. If my upload goes through, I don't see why it wouldn't. This is going to save to my computer, and then I can upload it. Okay, go ahead and do this one. They get harder, so we started out easy. These will get more and more difficult. Let's see. Let's give you a minute to do this one. Go. You could do what I did here.
This is so easy.
Lay out all your pieces. Go ahead and mute yourselves unless you're going to have a question. Okay.
Just so you know, I'm muted, but if you hit the spacebar and hold it, you can temporarily unmute yourself to ask a question.
Great. That's good advice. Thank you. See if I can get a better marker. I ordered a whiteboard and more markers with different colors, so hopefully those will be coming. Okay, so I like to label my bases, and I have the front and the back. See how I'm doing that? Now, what do I need for a triangle? So we all should be well equipped from chapter 10. Whatever I throw at you for a base, you know, even if it's a regular octagon, right? And I give you the radius of the octagon, you all know how to find the area with your trigonometry to get it. So.
And then I have the self-made algorithms.
Okay, but look, here, this is an isosceles triangle. You are not given the height here. Okay, so there's all sorts of ways you can use heron-ons, right? How else would you do this? How are you going to find the height?
It's a 3, 4, 5 triangle.
3, 4, 5.
It is, isn't it? Because
Yeah.
if it's isosceles here, okay, then this splits it, this perpendicular segment, this altitude is going to be the perpendicular bisector of the base.
You could also do 1/2 BC sine A, but that would require a lot more math.
Okay, I like that. Okay.
Not regular, Daniel.
So this is 3, this is 3. Okay, this whole thing was 6. Okay, so then you have the 4 there, and now I have the height. So half the base times the height, and you get 12, and there's 2 of those, front and back. So I'm going to call this one 24 is going to be for the both bases, the base in the front and the base in the back. Okay, now, now if there are n sides here, then there are n lateral faces. So if this is a triangle, you will have a lateral face for each one of those. So let's go with the one on the right. They're not always going to be the same. This is a 5 by 12 rectangle, so this one is 60, and there's not another identical one opposite that one. So that is a solo. So that's a 60 right there. Is it a Ben solo? Just kidding. Sorry. You know I'm a Star Wars fan. Okay, rectangle in the back is actually 5 by, this distance across is also 12. So the one in the back is also 5 by 12. And then I need the rectangle on the bottom.
6 by 12.
Yeah, it's 6 by 12. Okay, and that's 72. And now you can add it all up. So you have 120, 192, and 216. So surface area is equal to 216 square centimeters. Okay?
We just go down.
Go down.
It's lagging like hell right now. I mean, it's just like, the screen is literally frozen.
Your screen is frozen?
Not frozen.
Your screen might be frozen.
It's like,
it's
it's moving, but okay, now I think it's fine. It was just lagging.
One of the good things about Zoom is that
like, moving is just lagging.
I'm not getting any lag like I did. If I had a 5-second lag in the last video, so.
Eli,
Hey, any questions about this? I'm gonna move on.
Wait, did you guys know that you can raise your hand in this thing? There's a button that says raise hand.
Yeah, I knew I could.
But you know what? We don't need that right now. If that becomes an issue, you can bring that up. Do you think that that's a solution? Okay. So that's your formula right there. It's lateral area plus 2 bases is how you do this. Go ahead and do this one. Good practice.
$216 in binary is 11011111.
All right, thank you for that. Let's not distract from what we're doing, though. I like that, though. For me, I like to lay out the area of my 2 bases first. Usually that's where the meat of the work is. Okay, and then you just get the area of the rectangles, the lateral area. Sometimes a question, like when you go to the homework, it might just ask for the lateral area. Okay, you see that in like soup cans, because they what do they do with the soup can? They put a label around it, right? So you have this label that goes around your soup can, but the top is not labeled. So what they'll ask is, what is the lateral area? All right, so that's when they would just ask for lateral area. And that's just one example, okay? But, so you should understand this as 2 separate things, because sometimes they'll just ask you for one or the other. Okay, let's start in on this. We have this right triangle here. It's a 3, 4, and it's gonna be a 5. Okay, so the area is gonna be 6, and there's times 2 of them, top and bottom. Okay, so that's gonna make this 12 for the 2 bases. Okay, and then I can separately go after my lateral area. So I have the rectangle in the front is 6 by 5, so that's 30. I have the rectangle on the back right there that comes like that, over here.
6 by
4 by 6.
1010111.
And then
Wait, what?
The one over there.
Where did you get the bases from?
Okay, hold on. I'll do that for you.
It's a right triangle.
Okay, the bases. Yeah, this is a right triangle, right?
Mm-hmm.
3, 4, 5. Got it?
1/2 people.
B squared equals C
You can use the Pythagorean theorem, but this is a 3, 4, 5 right triangle.
So isn't the base 5?
No, the
Well,
area of the base.
It's the area. Yeah, this is the area of the base. This 5 is this length, but that's the hypotenuse. To find the area here, it's 3 times 4. It's where the right angle is, Daniel. See it?
Okay.
So the 3 and the 4 make up the base and height of that triangle. And then I do half the base times the height. But then there's two of them, right? Bases. Okay, so then we put them all together. So here we have 42, 72, 84. Surface area is equal to 84. Okay? Any questions? No? Okay, moving along. Good job, everybody. The formulas, when we derive them, are going to be fun. Okay.
What's
So
the angle A plus 2B mean?
there's going to be a new formula that we're going to come up with here. Here's what I want to, before we go to it, I just want to show something about this. We are going to, just like we had 1/2 AP, we are going to find another formula for finding the lateral area, possibly a little faster with different information. What I want to do is I want to break this down. Let's just forget the 2 bases and only look at lateral area. Okay? What do you notice? We're going to do this by induction here. So just from this example, you're going to see that this is true. Okay? So if this side is 5, you have, let's do the rectangle on the left is 3 by 6. The rectangle in the middle is 5 by 6. And the rectangle on the right is 4 by 6. And what I'm doing is I'm doing 3 times 6 plus I'm doing 5 times 6 plus I'm doing 4 times 6. Those are the areas, right? That's how you got an 18. That's how you got a 30. That's how you got a 24, right? Can I factor something out of all of these? What can I factor out of each one?
6.
The height, right? The height, you can factor out the height of each one. All right? So if I factor out the 6, what's left is 3 plus 5 plus 4. So remember, I factored out the height, and what was left was 3 plus, what is 3 plus 5 plus 4? Anybody notice anything about that? 3 plus 5 plus 4?
The perimeter.
12.
It is. It's the perimeter of the base, right? So what's left when I factor out the height here, down here, is the perimeter. Okay? So what did I just show? I showed that the lateral area is going to be the perimeter times, I'm going to call it big H, right?
pH. Acidic or basic?
Yep. The lateral area is always going to be the perimeter. Perimeter of what? That's important.
The base.
Perimeter of the base times the height of the prism is going to automatically give you the lateral area. Okay? So that's an important thing to remember, and that will help with this formula when you need to use it. It'll help you remember that. Okay, so here you have it here. The lateral area is equal to perimeter of the base times the height of the prism. Again, this is from the textbook, so they use lowercase letters. Okay? And then for the surface area, it's just the lateral area plus the two bases.
Will we have
Right?
to prove
So
this on
put
the
them
dice?
together. Go ahead and substitute this in for lateral area. And then you get your formula, which is what? Can you guys do that? Substitute this one in, pH in there. What do you get? Surface area
H plus 2B.
is you get pH plus 2B. That'll work for all prisms. Okay,
So
that'll
what does
work.
pH stand for?
Perimeter of the base times the height of the prism. So
Okay.
you might want to take notes of that. Take note
And the
of
way that you,
Go ahead.
sorry, the way you prove theorem like 11.1 is you factor out the 6. That's what you were just doing.
Yes, I was using induction to show that. Okay, but that works for all of them. All right, remember there are always going to be n amount of if there are n sides to the base, then there's going to be n faces. But all of those faces will have the same height. All right, because the connector that connects the two bases is going to be the same for all of them. Okay, so that gets factored out, and then when you add up all the rest of the sides, it will always be the perimeter no matter how many sides the base has. So that formula will be true of all of them. Okay, moving along. Okay, now they move on to cylinder. So we think of this really not any differently than the polygon. So what I would like you to do is I would like you to think of the cylinder as a polygon, regular polygon of infinite sides. So it becomes a circle, but all the properties, so what would be the perimeter of a circle?
Circumference.
Circumference. So watch what I do carefully. I'll take out perimeter, I'll put in circumference. This should be big H because it connects the two bases. That's the same, okay? That should be the lateral area plus the area of the two bases. Now with a cylinder, what is circumference? 2 pi r?
D pi.
Yeah, we do d
Or-
pi. We can do d pi, but let's just do 2 pi r for right now times big H. And then what is the area of a base? It's the area of a circle, right? So what's the area of a circle? Pi r squared. So you have 2 pi r squared. Okay. Now the book stops there, but if you notice, you have common factors. You could factor it out to shorten your formula. Okay? So you can get a 2 out, a pi, one of the r's. So you can take a 2 pi r out, and what would be left is h plus r. And that is, go all the way back up to the top, that would be the surface area of a cylinder. This one is more intuitive because I know what I'm doing. This one, I know what I'm doing. Circumference times height. If you want to unravel it, like we did in the beginning, right? Remember that? Remember, this wraps around the circle. This wraps around this circle. That's the circumference. This is the height. Remember, C times H gives you the area, the lateral area. That's what this is explaining. Okay? The two bases is base 1 and base 2. Okay, so you're finding the area of those. That explains the two bases. All right? So to me, this one makes sense. This one, when I look at it, it's not intuitive. This one would be memorized, if you like to memorize the shortcut formulas, okay, which we've been doing lately in the class. Okay?
A equals
If you
N
notice,
A
hold on. If you notice, I have not been looking at comments because you guys are able to unmute and say stuff. So I have not been looking at comments, just so you know.
Okay.
Okay. But anyway, this formula is a very shortcut formula. What do I need to give you? Radius and height. So if I give you a cylinder, right, and I just give you this information, radius is equal to 5, and I tell you the height is 10, call it centimeters, you could just plug that information in here. 2 times pi times r is 5, and then multiply that times 10 plus 5. And you get the surface so fast. Just by, 15 times, it's 150 pi. Look at that.
That's only for a cylinder, right?
Right. That's the surface area of a cylinder. So you can see how memorizing this formula, but you should be able to derive it. So you could always, let's say it's 10 minutes before a test and you forgot. Go ahead and sit there and derive it quickly, and then you'll have it with you right before the test. You don't have to memorize it long term. I didn't. If you had asked me before this lesson, right up until we did this, I would not have remembered that. I did not remember that. Okay? But you can see if it makes sense to you, you can figure it out yourself. Okay? Writing at the bottom. By the way, you can tilt the cylinder too and get an oblique one.
So
What
before
proofs
each
will
test,
be on the test?
Okay, let me just see here. It's the same thing that we said before.
for each test, should we be just memorizing like just like formula?
9:30.
It's close to 9:30, but I don't want to stop yet.
It's 9:30.
I want to stop at the end of this lesson, so we're getting very close. We derived this already. See it? 2 pi r is the circumference times, that should be capital H, height of the cylinder. Okay, that's using the diameter. And then the two bases make up this 2 pi r squared, 2 base areas. So if you just look at it carefully, it looks like a jumbled mess. But when you look at it carefully, you can make sense of each piece. So we're just going to try a couple, and then we'll close out the lesson. So everybody, let me get rid of the formula so you cannot see it. If you took notes, you have it. If you don't, see if you can figure the surface area out. Don't shout it out, please.
So for the test, should we just like a few days in advance be memorizing each of the formulas for each area?
I don't like
I mean, you don't necessarily have to. Most of these are just derived from the definition of surface area and the definition of lateral area.
Okay, let me answer the question.
What is the test going to be?
Hold on. In geometry, there is really the two ways, probably in all of math, 2 ways to go about doing it. Okay, I call it type 1 thinking. Type 1 thinking is memorizing. We did that. Some of us did that in algebra. Here's a certain type of problem, and this is the way you do that type of problem. Step 1, step 2, step 3, step 4, problem is solved, and you just memorize basically like an algorithm. And I don't want to say that that's bad. That really helps you do things quickly. So if you're using it in the job, on a job, you do want to be able to access things quickly and not have to Google it or look it up. It would be nice to have those on hand. So type 1 thinking is very useful, but it's really important to have the type 2 thinking. Type 2 thinking is understanding why it works. Okay? Understanding why it works. If you only memorize, what happens is as you go through math levels, it gets more and more difficult to hold all of it in your head, especially in this chapter with all of the formulas we're going to be studying. So you really need that type 2 thinking this chapter more than ever, because you're going to have, 40, 50 different formulas, okay? And then it's going to be hard to remember them all. And
Right. No, sorry.
But if you have, what you want really is both. You
Okay.
want both types of thinking. You want to first understand why it works, and if you happen to forget, you can always derive it, okay? That's what you're seeing me do right now. So
Okay.
imagine if you have enough skill to do both, you can pull things up quickly. That's like your random access memory, right? You can pull it upon, pull it and use it quickly, all right? But you want that ability to solve the problem without knowing what it's going to be ahead of time. And you can't do that just by memorizing different ways of doing problems. You have to understand how it all works. Okay, now I think you've had enough time to do this problem.
Wait, when will the test be?
When we come back, we'll review everything, take a test. If we finish 2 chapters, let's say we finish 11, we still have to take a test on 10. We'll review for 10, take a test on 10.
Oh, no.
11, take a test on 11, and so on and so forth.
Too many tests.
Don't worry about it. Listen, review does not mean 1 meeting. It could mean that we take 2 meetings to review, and we'll review until everybody is comfortable. Okay, the surface area is the lateral area plus the 2 bases. Okay, all right. So if you remember that other formula, I remember that. Let's see if I remember it. 2 pi r was what was in common. What was left was an r and an h. Okay, all right. So I like that. Okay, 2 pi times the radius of 4, and then 4 plus 6. That's really simple to do. So this is 10. So 80 pi. Leave it in terms of pi. Square centimeters, and you can whip that out really quickly, all right, if you have that. If you have this shorter formula. Now, if you do it the long way, that's fine. The longer way. It's still not that long. Questions? I don't get how you got 24 for the triangle. Can you go over that again? That was a while back, right? It doesn't say when that message was. Go back. Okay, let's... Okay, I love this problem. Okay, this is you have to use it. I'm going to let you guys try to use the math you just learned. You're going to have to try to figure this out. This is called a drum, okay? So this steamroller, imagine some point on there. It's going to roll out, and look at the shape that it rolls out, okay? I don't want to say anymore. What area does the drum cover in 1 full turn? The diameter of it is 2 feet. The width across, or the height of it here, if you want to say that, is 4.2 feet. Okay, 2 questions. What area does the drum cover in 1 full turn, and what would it be in 2.5 turns? Go ahead and take 1.5 minutes and do that. And this one will finish up our lesson.
Do you want this in terms of pi?
Sure. If you want to, well, no, you know what? Let's do 3.14 with pi, because this is already in decimal form. So let's go ahead and use 3.14 to approximate pi. I can't go too far over because I have my 6th grade group coming in soon. So virtually coming in. Half of our geometry group's not in here because I only have 52 participants.
That's not good.
No, it's fine. A lot of people are going to watch this later, so hello to all of you that join later.
26.376.
Okay, let's not shout that out. Let's see. Maybe somebody got something different.
26.4.
Another 30 seconds, and I'm going to start going over this. You had to make sense of what they're asking for instead of just following a formula. You had to realize to leave something out. I wonder what you're leaving out. And time. Okay, let's take a look at this. If a student memorized this and loves it so much, they want to snuggle with it, and it's just so great, it helps us solve it so fast, this would be wrong. Why?
Because.
Why would this equation not, or this expression not work?
Just the lateral area.
Yeah, because that's, yeah.
Exactly. you don't want the base area here because that's not making contact with the ground. Only the lateral area is making contact with the ground. So this formula might not help you in this case. So you have to go back to what is the lateral area? The lateral area is the perimeter of the base times the height. Okay, so I need the circumference. The circumference is pi d. So this is going to be, or d pi, okay? And the height is 4.2. And the diameter is 2. So it's 2 pi times 3.14 times 4.2. Okay, so we have, let's do 8.4. Okay, 16.
Oh.
Hey, is that what you guys got?
Yep.
Okay, so what is that? That's the lateral area, right? In feet squared. Okay? All right. So that's what one revolution of this drum is going to produce in area. Now, how would you expand this to the next problem? In 2.5 turns, how much area? What would you do? You would just multiply this times 2.5. Okay? And we don't need to calculate that right now. Any questions about that?
Wait, so you found the lateral area is the area of the circle times the area of the height?
It's the circumference times the height. Right? Because look at the ground here, Daniel. What shape is this? It's a rectangle, right?
Yeah.
So that's a rectangle. So what's this distance? It goes around, that's one full revolution. That's the circumference. And then across is the height of it. It's the 4.2. So this circumference you can find with the diameter times pi. And that's what I did here. The diameter was 2 times pi times this. Basically finding the area of the rectangle is actually what you're doing there. Okay? All right. I think we're ready for our favorite part.
Homework.
There it is. Look at all those problems. Look at all that.
Oh my god.
All those problems you have to do.
Please, no. Please.
Okay, while you guys are writing down that homework assignment.
Not even that hard.
Does anybody want me to go back to another one of those problems?
Wait, that's only 10 problems. That's not even that many.
Not. Anybody want me to go back to anything?
Oh, the horror. All these problems.
think we get it.
Wait, I have one question. So you multiplied the circumference, you multiplied 2 by 3.4 by 4.2, right?
In this one?
Yeah.
Yeah, so it's the lateral area is the perimeter of the base times the height of the cylinder, right? So how do I get this distance here? It's the diameter here, 2.
Yeah.
Pi. So you see that here.
So why did you only multiply 8.4 by 3.14?
Commutative property says I can multiply in any order, right? So 2 times 4.2 is 8.4. 8.4, right? I just multiplied out of order. Okay?
Yeah.
There's no out of order in multiplication. It's called the
Back to the homework. Hey, I'm going to put this up on YouTube so you can always go back and watch this again and get the homework. Or you could email a friend or text a friend for what it is. But there it is.
Oh.
Take a screenshot. Okay. All right. So I think we're good for now. I got to get ready for my next class that's coming in 20 minutes. So I'm going to post this later on today. After I'm done with my next pre-algebra class, then I will post both of them on YouTube on my channel. Okay, and everybody has access to my channel now.
I can't see the screen. Oh no.
That's because if I come close to the camera, it changes it. So, yeah. So go on Schoology for any updates to get to my YouTube channel if you haven't already subscribed. That's where you will find this later on today on YouTube. If you want to
like and subscribe.
Okay. All right, everybody. Have a wonderful day. Stay safe. Try to do what, social distancing is very effective right now. So hopefully that will do the trick and we can get back to school sooner than later. All right? Have a great day. I'll see you guys tomorrow.
Thank you.
Thank you.
Thank you.
Bye.
Okay.
Bye.
Bye.
Bye.